Hi everyone. We'll just give it a couple more minutes to allow more people to join. Thanks for joining us today. Hi everyone. Please just bear with us for 2 seconds. We're just some small technical difficulties just trying to work through. If someone could just at least say in the chat that they can hear me, that would be great, and hopefully Matt can join us in a second. Hi, everyone. Sorry for that delay. I think we're okay now. Matt, can you give a thumbs up if you can hear me now? Brilliant. Thank you for everyone's patience. And welcome to this week's Brown Bag. I'll keep the intro short so we can go straight to the great quality that Matt's going to talk us through in terms of right data, right users, right time. So just a reminder, I think everyone's on mute. That's great. And video off helps with the streaming quality. Any questions, submit them via the chat. Yeah, we'll try and make it interactive like we have done in the past. Plenty of time for questions. And today's session will be recorded and published on YouTube channel. If you have any feedback or want to, inspired by some of the topics that we've talked about or talk about today, please don't hesitate to get in touch, forward, share, invites for future sessions, and yeah, we'll update for everyone that's registered on the email list. So without further ado, I'll hand over to Matt, who's Senior Data Engineer at Eliiza, to talk about this great topic. Thanks, Matt. Matt, you need to unmute yourself, so hopefully we can hear you. Brilliant. Off you go.
Right. Sorry, okay, so thanks for holding on. I've had certain technical difficulties, typical engineer getting things wrong. Anyway, so as Graham said, my name's Matt. I'm a data engineer for Eliiza, and today I'm going to be talking about data enablement and getting the right data to the right users at the right time. So kind of why this talk, or why this topic? So what I'm finding is, as the use of data in companies is maturing, it's been a real shift in focus of data projects from kind of single problem, single solution issues, where we're kind of reacting to clearly defined problems and we're using data to create a solution. We're moving from that to projects where the focus is more on giving these various users in a company access to the data and tools they need to proactively find solutions to the problems which haven't actually been identified yet. And we could see this in the language that companies are using around kind of data projects. So rather than talking about single issues, we're now talking about things kind of broader topics like data enablement or building data platforms, creating data democracies, making data-driven decisions. So we've really moved from the kind of more specific to the more broader general kind of problems at hand. So this is all great, but what this means is we actually need to change the way we provide these solutions. So rather than analyzing things from a kind of purely technical or problem-specific viewpoint, that's kind of just looking at the problem we need to solve and going straight into solving it. We need to start looking at things from a user-centric viewpoint. So actually kind of saying, well, what are the types of problems that need to be solved by our users? And kind of, users are unique. People in a company are unique. They have different use cases and requirements for data. And that really varies on their role, their experience, and their knowledge. And so, yeah, so the success of these kind of data enablement projects really depends on taking these needs into account and actually delivering kind of what our users need. And so delivering these capabilities is really important. Data enablement projects are still fairly risky undertakings. And true to form, I kind of just scraped these stats from the internet, but they kind of show a pretty horrific problem out there. So yeah, 85% of data transformation projects fail their desired outcome, and that's from Gartner. 77% of the executives report that business adoption of big data AI initiatives is a challenge. And the real kind of standout stat here is that 93% of these kind of hopefully executive respondents kind of identified people and processes as the obstacle to kind of success in these projects. So this presentation is really for anyone who's involved in or undertaking a kind of a data enablement project, and hopefully show how we can ensure that we're properly taking into account and addressing our users' needs. And then from that, hopefully we can lower this fairly horrific statistic. And so a good summation of, or kind of mission statement of what we mean when we talk about data enablement or data platforms, or data democracies, it's quite simple. It's to get usable data to the people who need it for their day-to-day tasks, or in other words, getting the right data to the right users at the right time. So this is lovely, but yeah, how do we reach this state of data nirvana? And there's 3 questions to achieve this that we need to answer. So the first one is who are the users, and kind of, you know, if we identify users, what do they need from when it comes to data, what we need to provide to them. The second is what is usable data, and more importantly, what is usable data in the context of our users, because you know, potentially they've all got different needs. And then thirdly is how do we actually get that data to the user? How do we structure and process it so we're filling the requirements? So let's look at the first question. So who are our users? And one of the interesting things I find about data projects compared to more software projects is the amount of users that a data project can potentially touch. So typically with a software engineering project, you're building a feature for a specific user. So like a dating app for cats or driving lessons for the under 5. Whereas with data projects, the user base is a lot broader, and it really ranges from the very technical on one side. So here we've got like data scientists and software engineers to very non-technical. So they may be C-level executives on the other. And you've got kind of internal business users like account managers or operations staff. But then on the other side, you've got, who those guys have good domain knowledge or business knowledge. But then on the other side, you might have providing data to external customers, you know, such as, I don't know, with a banking app, you've got customers who are just looking at their banking details, and they don't have really specific domain knowledge, and they don't really care about the internal workings of the business. And then also, and quite forgotten, is also we kind of range from the human side of things to the non-human side of things. So consumers of data are also other applications in your companies, or for example, like machine learning models. So the problem is we don't want to be creating specific solutions for each user, because that kind of gets us back to the early and the reactive single problem, single solution issue, where, you know, we analyze a single group of users and say, yeah, what do they need, and build a solution for that. You know, we really want to be building broader platform-based stuff. So what we can do is we can group our users into specific types around how they use data. And so here we can see we've basically got 3 different types of users. So on one side, we've got our data explorers. So basically their job or their kind of daily work is working with data. So they're used to kind of hands-on wrangling using the source or data. And essentially what they need to know, what their requirements are, is really they just need to know how and where to find the data, and they'll just get on with their work otherwise. In the middle, we've got data operators and analyzers. So for them, data is an input to their daily work. So typically they have good domain-specific knowledge about data, and typically what they're doing in their day-to-day work is they're kind of getting data and joining data from different sources and building data from that data. And then lastly, kind of on the far right, we have our data readers. And so really they're using data as an input to drive decisions for their daily work. So typically the data at the point they want the data is to be merged across different domains. It's already been joined and it's been cleaned. And usually they're using this data to get specific answers to specific questions. And they're not interested in exploring or wrangling or anything. They just want to get the facts, the answers that they need when they want it. And then we can also look at the users in terms of how they understand data and also how much we trust them with data. So again, on the far left, we've got data explorers. And so they've got a kind of a high trust, and we trust them to use our data. They're very aware of inaccuracies in the data. So they know that there's going to be fraud or duplicates in the raw data they're looking at. They're very skeptical regarding results they get from kind of querying that data. And so we can kind of trust them with data, because we know that they're going to be careful of what they kind of get from it and what they do with it. With the data operators and analyzers, we've got a kind of medium trust with them. Usually they've got a bit of technical knowledge, they understand the limitations of the data, and they're prepared to put in the work to kind of get the results they need from the data. And then again, on the far side, we've got our data readers, and we've got a low trust with this group. They haven't got any tolerance for the limitation of data, and they've got no tolerance for discrepancies in the data. So really, the data they need to get has to be spot on, it has to be accurate. And there's really high consequences for inaccurate data at this level. So if we go back to the same example of an external customer using their banking app, if we give them the wrong data, if we give them the wrong account balance or even the wrong account details, there's serious consequences for that. So at this point, there's a real low trust for our users. They don't have any give and take when it comes to using that data. And then so what we can do, we can actually split our data users that we identified earlier out into these different groups. So with our data explorers, we're looking at basically kind of data scientists and data engineers. As we've seen, they want to be as close to the source of what data as possible. And really their concern is just access, getting as much access as possible to the raw data. They don't want any filtering from that data. But also, we can trust them with that data because they know what they're doing with it. Again, in the middle, we've got data operation analyzers. And so they're people who've got good technical knowledge or business domain knowledge, such as our business analysts or operations staff, software engineers, machine learning engineers. And so they usually have strong technical skills like software engineering or SQL. And then in case of, say, operations or account managers, they usually have strong domain or application knowledge. So they're aware of kind of flaws or problems in the systems, and then they'll take account of that. And again, on the far side with data readers, we're really looking at the more kind of management side of things with the executives or finance, HR, and sales, or kind of external customers or people like compliance or regulators. And so they just want to make decisions with that data. They don't want to manipulate it. They don't want to do anything to it. They just want to read that data. And so we can kind of get our data users kind of what they need and our kind of different groups. And we can look at it in terms of data maturity. So again, data explorers, they have a real high maturity of data. And what we mean that is as we said, they have a good technical knowledge, they know what they're doing, they can be trusted with the data. So kind of, in a sense, they're like the adults of the data world. We can kind of let them loose on data. We know they've got the responsibility and the knowledge to not kind of come up with incorrect results. They'll check that what they get is correct. And a lot of work, say, a data explorer will be doing is verifying that their results are correct. And typically, there's fewer users of data explorers, and they have pretty general needs, as in they just want to get access and they want to do what they can to the data. On the far side with data readers, they've got a low maturity of data. They don't have the knowledge. They even want to manipulate data. They just want to get the facts given to them. And typically in a company, there's going to be a lot more data readers than there are data explorers. If we look at a medium-sized company, typically you'd have, say, 5 to 10 kind of data explorers, and that'd be kind of data scientists and data engineers. And then you might have between, say, 50 and 100 operators and analyzers. And then the data reader groups, you're looking at kind of 500 plus of data readers. So there's a real kind of exponential growth in terms of users along this kind of data maturity line. So we've looked at the users and how we can split them up into our groups. But then the next question that we need to answer is what do we mean by usable data, and kind of how does it comply with our users' needs? So we've got the 3 A's of usable data. That's accuracy, availability, and accessibility. So accuracy is kind of what it says on the tin. It's really about, does the data contain discrepancies or duplicates? Does fraud exist in the data? Are there nulls? Is it IDs or names? And the kind of one of the major ones is it a single or multiple sources of truth there? So this is really important for accuracy, because typically, if you have multiple sources of truth, that's where real discrepancies can lie. If you're aggregating results, to get kind of a daily aggregation of units sold, if you've got multiple sources where you can get that data from, or get that result from, there might be discrepancies between the two. When you're dealing with a single source, hopefully that should be always correct. With availability, that's really about how easy is it for the user to query the data they need. Does the user need special knowledge or skills to query the data? Is it available to be queried using, say, SQL, or is there a nice web UI they can use? Or will they actually have to code their own MapReduce job? How explorable is the data? Are they kind of given data as a static report, or is it open for them to explore? And then the third one, accessibility, is how easy is it for the user to find the data they need? So typically we're talking about kind of curation of the data, cataloging the data. Is the data schemaed, or is it kind of just kind of unschemed JSON? And even like stuff like kind of security, like PII, like has PII information been redacted? Can this data be kind of shared among others? And then we also have, with accuracy and kind of availability, we also can talk about SLAs, service level agreements. And what we mean here is kind of particularly in say accuracy is there any guarantees around the data? An example is, say, with say online advertising. With accuracy in online advertising reporting, you need about, I think there's a 15% discrepancy allowed. Whereas say in something like banking, you really are not allowed to kind of any discrepancy in the data. So when we talk about data quality or data delivery SLAs, that's kind of giving guarantees around how accurate the data is, or how available it will be. And so we've got our kind of criteria for usable data, but then we can actually put it on a spectrum of usability. So kind of one end of the spectrum, we have low usability of data. So if we drill down into the 3As, we've got kind of for low usability of data. When we look at accuracy, we're kind of looking at low correctness. Data is kind of as is. You know, there will be nulls present in the data. You know, you'll have IDs rather than dimensions. It'll be pretty hard to join data from different sources when it's kind of low usability. And typically you'll have multiple sources of truth, and you won't really have any SLAs around the data. It's very much as and when and as is. When we look at availability for low usability, you know, typically we're looking at a large volume of data. So querying that data can take a long time, like it can take up to hours to get the results you want. And users typically will need to be able to code to access the data. So that'll be either through SQL or potentially even through kind of coding up a MapReduce job to get the data they need about. But the benefits of this is that it's very explorable. You can kind of find out, if you know what you want to find out and you know how to get it, you can really find out kind of what you need. And then when we look at accessibility, again, the data is not curated. It's probably going to be very shallow cataloging. So that means, you know, typically it'll be by source and maybe even kind of divided up by date or partitioned by date, but there won't be any kind of indexing. Potentially won't have any schemas, so you need to know what you're looking for and be prepared for changes happening. And also in terms of PII, there won't be any kind of PII kind of security kind of redaction. So there's no sharing of this data. You can't just kind of pull out your results and send it off because potentially there's PII security issues there. And again, when we look at the SLAs for low usability, typically there's no or very low SLAs. So we're not guaranteeing accuracy, and we're not really guaranteeing any kind of availability for queries or query speed. And then kind of on the other side of the spectrum, we can see here we've got a high usability of data. So with the 3As on this, when we look at accuracy for high usability, we're kind of saying results are going to be accurate. And with a production level SLA on this, typically if the result isn't accurate, it's a production level problem. Like someone will have to go and fix that in a certain minimum amount of time, and there's a guarantee put around that. Typically, it'll be very easy to join data from different sources, and quite often you'll be trying to get a single source of truth. So, results will come from one source rather than potentially multiple. When we look at availability, typically it'll be a fast speed to queries. So rather than taking hours to get your results, we're looking at kind of sub-second results. And again, there'll usually be SLAs or guarantees around that. And in terms of querying the data, it'll preferably be through some sort of web UI or reporting interface or an API rather than actually having to write your code yourself. Now, the trade-off with this is if it's not explorable. Typically, you'll be running defined queries or receiving a static report. However, in terms of accessibility, it will be very easy to find needed data. So data will be indexed. Typically, it will conform to a standard or a schema, and PII will be removed, so it can be shared around. So what we can do, we can actually kind of take our data maturity from our user groups, and then map it to the usability of data. So what we can see, we've got our data explorers who've got a real high maturity of kind of data usage. And typically they're the ones who are interested in dealing with low usability of data, and they're the ones who can deal with this kind of data. Because above all, they're prioritizing access over all the data versus kind of the ease of querying that data. However, on the kind of far side of the spectrum with our data readers, they've got a low maturity of data. So typically they can only deal with data which has got a high usability. They just don't have the skills or the time to be dealing with kind of data where they have to wrangle the data to get the results they need. So this is all great, but how do you actually get data to the users in the form that they need? So this is a data pyramid. It can also be shown on its sign as a funnel, but I like the pyramid. And what it kind of really shows is the flow of data from the bottom, which is the raw or ingestion layer, through the different types of layer for use. And so we've got the raw layer on the bottom, and we've got the kind of process operational layer and delivery layer on the top. And so we can see how the data is processed and curated through different layers. So in the raw layer, data is ingested from our sources. It's typically taken in on any format. There's no filtering or deduping, and it's very much a kind of use at your own risk type of affair down here. Once the data's been kind of identified in the raw layer as useful, then it can be promoted up to the process or operational layer. And then part of that promotion is typically to start standardizing the data, for example, identifying and adding a schema, and maybe carrying out some kind of standardization of dates or IDs, and potentially de-identifying users or removing and tokenizing PII data. And then moving the data into a system which kind of allows easier access and manipulation. And then once the data is in the processed or the operational layer, then it's in a better state to have further processing, such as aggregation or joining with other data sets, and cleaned and wrangled into more useful data. And so this kind of cleaning and wrangling kind of takes place in this operational layer, and kind of, as I said before, we're kind of creating data from the data we're receiving. And then the final stage is to promote this data up to the delivery layer, where it's ready to be consumed by users and applications. And again, at this stage, the data kind of gets moved into more specific kind of user storage. So the data is ready for delivery, and it's kind of very clean. It's ready to be consumed by the users. And we can actually kind of see each layer as optimized for its use. And the raw layer is really optimized for storing and searching through large amounts of data. The processing layer is really optimized for accessing and joining and aggregating data. And then the delivery layer is kind of optimized for fast querying and delivering the data to display or to end users. And so essentially, we're creating data from kind of a low usability at the bottom raw layer to high usability in the top delivery layer. And so we can actually get our kind of data user groups and their kind of levels of maturity and see how it corresponds to the layers in the data kind of pyramid. So at the bottom, we've got our data explorers who've got our high data maturity. And they really match the use cases for the raw layer, where the data is all there for it to explore, but it's a kind of painful and slow process. Data operators and analyzers kind of in the process or operational layer, where they can kind of clean and join and aggregate the data. And then data readers, really they're only interested in the delivery layer, where the data's been kind of optimized and aggregated for them to view. And so kind of a real world example of this would be, for example, say we look at, say, clickstream logs for online advertising companies. And so in this case, logs would kind of come into the raw layer. And, we've been looking at kind of, potentially millions of events per second or log lines. And so this is a huge amount of data. And typically only at this stage, really only a data engineer or a data scientist would be interested in looking at this data. For a data engineer, pretty much they'd be looking at extracting the valuable data or the data that's needed, doing a bit of cleaning and pushing it up into data operators layer. And then in the operational layer, they might perform kind of aggregation on these clickstream logs, bit of cleaning, and really pushing those results up to delivery layer, where they can be viewed in a kind of a reporting system. And then for, like, say, a data scientist in the raw layer, they're kind of more interested in exploring maybe a subset of the data to find out potentially useful information. And then once identified, that source of data would be, again, pushed up into the process layer, where, for example, machine learning engineers could use that to build models. And those models would go on to be used by the delivery layer to, for example, help with, for example, a chatbot or something like that. So we can also drill down into these layers using our 3 A's of data usability to see how each layer in the pyramid satisfies the requirements. So if we look at accuracy, in the raw layer, we've got a low accuracy because everything is pushed in here. So there'll be multiple sources of truth, there'll be fraud or duplicate data is present. But that's kind of because we need that data there. For example, a data scientist might be looking into kind of fraud detection and fraud prevention. So that's why they need all this data here for them to really explore and use. In the process or operational layer, at this point, we should have a high level of accuracy. But the issue here is that because we're the kind of operators at this layer are creating data from data, it's very possible that they will introduce incorrect results from kind of this joint data. So there still needs to be a level of kind of a verification, and you still need to be able to trust them that they're going to check their results before they push it up into the delivery layer. And then in the delivery layer, we've got a high level accuracy. We should be trying to get a single source of truth, maybe a master data management, and really all fraud or duplication should be removed, and we should have strong SLAs around accuracy. So that means if any inaccurate data gets pushed up to this level, it needs to be fixed very quickly. And then if we look at availability, again, the raw layers contains all the data. So typically at this layer, the data is in kind of files on cloud storage, CSVs or log files, and it's going to be fairly unstructured, but highly explorable. And again, as we know, that queries on this layer will take a long time to kind of come up with the results. In the process layer, we should have a medium speed of delivery because we've kind of filtered the data up to this layer. We should be able to run faster queries on this data. And typically we'll try and kind of add schemas to the data of this layer, and then potentially use kind of potentially shrink our tech choices. For example, use a data warehouse or distributed SQL to query this data. So some kind of coding or SQL knowledge is needed. But really, it's kind of at this level, we're trying to make the data more available for use. And then at the top layer, the data is highly available through multiple channels. And quite often they'll be very specific for the use case. So for example, it might be emails reports or using dashboards or APIs. And again, around here, we have pretty strong SLAs around the speed of delivery. People don't want to be waiting hours for a report. They need it there and then because they're making decisions based off of data. And then finally, we can look at access and governance. And so in the raw layer, we've got a very few highly trusted users here. And so typically we'll have fairly coarse access controls. So for example, like bucket level access permissions. And we'll have a low level of lineage or cataloging. So typically, again, this will be down to kind of more like bucket or source naming and partitions, like partitioning on date. Otherwise, the data, you have to kind of explore and find data you need yourself. There's no real indexing or cataloging at this layer. And then in the process layer, we've got a certain amount of trust. So the access controls should be a little bit more specific. But more importantly is at this stage, you need to start introducing data lineage. And the reason is because the users here are creating data from the data. And so you need to be able to track back to see kind of where the data came from, what happened to it, what processing was applied to it, and then where it went. Because data from this level gets pushed up into the delivery layer and inaccuracies can be introduced, you really need that data lineage to be able to track back and find out if potentially where things have gone wrong. And also for access at this layer, you probably want to start looking at kind of gaining access through some kind of either metastore or data warehouse. So you're looking kind of a single way to access, query, and manipulate this data rather than multiple kind of choices. And then at the top layer, we're looking at large amounts of very immature data users who are data readers. And so we really need to get our fine-grained access controls here. And so quite often we'll be introducing kind of data catalogs or data dictionaries. So we're making it easy for people to find what they want, but we can also apply fairly limited controls over what data people can see. And again, lineage here is backwards. So because they're not manipulating data, we don't need to see what they're doing to it, but we do need to know where it came from. Because again, if we're pushing out inaccurate data, we need to find out where it went wrong fairly quickly and track that back down into our process or operational layer. And so far this has been all fairly theoretical, but we can actually use what we've kind of learned from our users and their data requirements to guide us in kind of our technology selection and implementation. And so when we look at kind of the raw layer, typically depending on kind of our data type and the volume coming through, we're looking at storing usually on cloud storage, so files on S3 or GCS or Azure. And then when we look at processing, typically the processing and storage can be or should be separated. So either we can look at kind of EMR or Glue or Dataproc Dataflow on Google, or if we're being kind of tech agnostic, we can look at Presto or Spark or Data Factory on Azure. And so here we're kind of separating the processing element from the storage element. If we're dealing with kind of smaller volumes, or the data is typically kind of already coming from kind of transactional database, and so it's fairly structured, we can actually start using data warehousing at this level. So for example, we could use a BigQuery, Snowflake, or Redshift Spectrum. And these technologies, typically, you can still separate the storage from the processing layer. When we move up into the kind of process operational layer, at this point, typically you would start introducing a data warehouse. So again, kind of Snowflake, BigQuery, or Redshift. If the volumes of data are high, you can still kind of keep it, sorry, if the volume of data are high or still kind of fairly unstructured, you can still use kind of distributed SQL to kind of query and process this. So it's be something like Athena on AWS or Presto or Hive. And again, at this level, you might start introducing kind of machine learning pipelines such as Kubeflow or kind of machine learning platforms like Databricks. And then at the kind of top or delivery layer, access is going to be usually through kind of reporting systems or kind of dashboarding systems such as Tableau, Looker, or Power BI or QuickSight, and then potentially application front ends. So, like I said, our banking apps or chatbots. And then the storage of data at this level is typically going to be specific to how it's viewed. And so this could be kind of in relational databases. If it's a reporting system, you might still want to keep it in a data warehouse. But potentially, especially for kind of application delivery, you might be looking at a key value store, document stores, and then maybe even kind of niche products like graph DBs. If you're building kind of know your customer systems, you might want to be pushing data into something like a graph DB. And so as we can see, we're really going from kind of quite broad general technology. And as we get up, we get more specific to the actual kind of delivering to the user's needs. Cool. So that's my talk. So in summary, any data-enabled project, we really have to start taking into account the requirements of the users and the groups that it will affect. And taking this into account can really determine what data we need to deliver and how we need to deliver it. And then the how can, as we've seen, can really guide our technical choices. And then hopefully looking at our users and their needs, requirements, and kind of using them to drive these choices, we can bring down that kind of shocking failure rate of 85% and really kind of start delivering our data enablement projects to success. Cool. Thank you for listening. Yeah, any questions?
Yeah, thanks a lot, Matt. Yeah, please, please everyone put questions in the chat if you have any. I've just got a couple to kick off, Matt, if that's okay.
Yeah, no problem.
Yeah, I mean, it's really interesting talk. I think it's great. The viewpoint of splitting into the different user groups and defining the usability categories is really useful as you look at data enablement in any organization. I'm just interested to chat a little bit about the layer structure of the data. I just wondered, sort of from your experience or from a top-down view, what are the main barriers, the main gotchas for companies trying to implement this vision of the layers and access for different users and things like that?
I suppose for me, for what I've seen in kind of past companies I work for, I think one of the main issues in kind of creating this system, or this kind of type of layer system, is typically the bottom layer, the processing from the raw layer upwards. It usually requires quite a lot of investment in infrastructure, time in infrastructure. And so typically nowadays, when you deliver kind of products, they see it from a user kind of endpoint. Yeah. And so if you're trying to build up a layered system like this, you really have to kind of push it forward as you're building a platform. And kind of a slice of delivering that platform might be an end-to-end goal to a user. But quite often it's quite hard to get that over to kind of the kind of people who are commissioning that in your company. And so they'll kind of pick a user, pick a problem and say, right, solve that problem. And so you've got to try and say to them kind of like, well, we will solve that problem, but whilst we're doing that, can we solve some of the bigger problem? And I found this in one of the last companies I worked for. We had to kind of negotiate with the board. So they wanted us to deliver data to a kind of a new UI. And as part of that, we said, okay, we'll do that, but can we build a data lake to deliver that data? And that's how we managed to get our data lake built, which meant we could build other features off that. But really, they weren't interested kind of in building a data lake. They just wanted to get the data to the user so they could build, they could analyze, data and make business decisions off that. And so I think part of the problem is trying to push forward that we're not just solving a single issue, we are building data platforms, which mean the company can start solving these problems. Yeah,
that's really good. I mean, just on that point you said about the companies are normally very focused on a use case or a user group that they want something delivered that often you have to try to piggyback on. Are there any of the user groups that you've defined here that are typically best served or least well served, or often the sort of focus of those maybe short-term priorities, and that it's harder for other groups to actually get the data sorted?
Yeah, so typically anything with sales or any kind of group which are kind of can point to that they're going to make more money from this data will get the resources given to them. And what I find is the kind of the squeezed middle. So quite often it's the people involved in, say, operations, or typically who will use data to increase efficiency in a company. They will get kind of pushed to the side. So if you've got a user group who say, oh, well, if you deliver this data to us in this system, we can increase sales or increase profitability by X, that will get the backing and that will go through. If you've got a group who say, well, we're spending ages analyzing this data, and it would help us to speed us up by an hour or so because then we can make some efficiency somewhere. Typically, that will get pushed to the back, and actually, quite often that's a mistake because what I've found in previous is that sales are usually very optimistic on what they'll achieve, and you can usually gain quite a lot of kind of savings through efficiency in kind of helping out the operations or that kind of middle section of the graph.
Yeah, that's the squeezed middle, eh? Cool. Again, repeat out, any call out of any questions or comments or experiences people have had, or just a hands up to, share some comments we can throw to anyone. In terms of you talked about, you had a previous slide on the tech choices. Are there any stacks that typically do this well in terms of different accesses for different groups and different layers, and I suppose data lakes in general?
I wouldn't say actually there's a kind of any real kind of what stacks would come out above the others. Amazon, Microsoft, or Azure, and Google have all pretty well kind of standardized almost their tech stack. So there's quite a lot of similarities across them. They've all got cloud storage. They've all introduced some sort of data processing, like kind of AWS has got EMR and Glue. Google have got kind of Dataflow and Dataproc, and Azure have got some, and I can't remember the actual names of them off the top of my head. So really, actually, they are kind of fairly getting quite standardized towards this kind of data lake and data processing on top. So I wouldn't actually be able to point out any kind of good ones over any others.
Yeah, cool. Yeah, no, it's interesting and reassuring because that means that whichever stack a company or an organization is using, that there's possibility and availability of the tools there.
Yeah. In the last kind of couple of years, they've all made really good grounds on kind of potentially shaky starts about 5 years ago. Now they're all really maturing into good systems.
Yeah. Great. Well, I think everyone's still digesting the really good content in terms of the different groupings and the way of viewing it. So just last call out, any questions? Otherwise, I'll just in the meantime just wrap up. Thanks a lot to Matt. We'll send out the slides and a link to the recording when that's sorted, and email details relating to our next brown bag. Normally in the next scheduled for 2 weeks time. In the meantime, if this has inspired you, please reach out. I think, Matt, on your next slide, you've got a copy of your email address there. We'll also email that out, and sort of usual channels. We open for any sort of discussion. And as I said at the beginning, any feedback on how these these sessions have been run and the type of content, and also any topics you'd like to suggest would be much appreciated. So thanks again, Matt. Really, really good content today. Really good talk.
Thanks all.